Hello, wonderful students. You're welcome to class again. All right. This is Mr. Olukorede, your online mathematics tutor. Okay, so we are going to continue from our discussion on mensuration. Okay, so today we'll continue with the solid shape we started. All right. So I want you guys to get your writing materials ready. Your pen, your bio, your pencil, everything, just get everything ready. Make sure you have your calculator with you because you are going to be computing one or two things for me today. All right. And don't forget to invite your friends. Let them know the class is about starting. And don't forget, as I join the class, make sure you greet the class, say hi, and also don't forget to tap the like button. So if you are new here, ensure you subscribe to this channel. All right. Okay. So let us just wait for some seconds before we commence the class. So you can quickly invite your friends. Thank you. All right. Oluwatosin Omalara, you're welcome to class. Okay. All right. Good evening. How are you? All right. Let's wait for others to join. Please, as you're joining, just say hi and you tap the like button. Okay. Yes. Let us start now. Okay. So let's look at the first question here. The question says a solid cube of side 8 centimeter is dropped into a cylindrical tank of radius 7 centimeter. Calculate the rise in the water level if the original depth of water was 9 centimeter. Okay, this is a WAEC question. So how do we solve this? Now, the first thing is to get the idea of the question. Now, the question says we have a tank and it's cylindrical in nature. Okay, we have water inside. Okay, this is the water inside the cylindrical shape. All right. So we are told now that the radius of the cylindrical shape is what? Is 7 centimeter. So we have this to be 7 centimeter. The radius 7 centimeter. So R is 7 centimeter. Okay. So now a cube of 8 centimeter inside is dropped inside this water. Now, the cube is dropped inside. Okay, this is the cube inside. Now, you know when you drop the cube inside, now the volume of the water will rise up. Okay, it will rise up at a particular level. Right, so the volume of the water will increase, and that volume is going to be the volume of the cube dropped inside the water. All right, so there will be a slight change here. Slight change here. All right, and that is what the question wants us to get. The question wants us to calculate the rise in the water level if the original depth of water was 9 centimeters. So that means the height of this water in the cylinder here is 9 centimeters. So H is 9 centimeters. All right, do you understand now? So we want to get this height. So now once this is dropped inside, so the height must have increased by X centimeter. So, and that's what we want to get. I hope you understand that now. All right. So now let us look at it. Now let's get the volume of this cube. What is the volume of the cube? So volume of cube is L raised to the power of 3. So, and that is going to be what? Now we have the side to be 8 centimeters. So that will be 8 times 8 times 8. All right, and that gives us what? 64 times 8, that is 512 centimeter cube. Okay, so this is the volume of the cube. All right, so now let us get the volume of this water inside this cylinder. Okay, so what's going to be the volume? So we have volume, the volume of water is inside the cylinder. So it's going to be taking the shape of the cylinder. All right, so it's going to be what? Pi r square ish. All right, so this is going to be the volume of the water inside the cylinder before dropping the cube inside. All right, so this is our h. So we have it as pi times r. R has been given. What is the radius of the cylinder? So that is 7. So we have times 7 square. Now times the height is 9. Okay, so this is the volume of the water inside. I hope you understand that now. All right, so the next thing I want to get now is the volume, the new volume. Okay, when this cube is dropped inside, the new volume is going to be the volume of the water plus the volume of the cube. So that means the new volume, let's call that Vn, the new volume. Okay, now that is going to be, it's going to take the shape of the cylinder. So that will be pi r square ish. So the only thing that will change is the height, because now it will have increased. So it's going to be 9 plus x. 9 plus x. I hope you understand that. So that is that. Now, the new volume is the same thing as the addition of the volume of the cube plus the volume of the water, okay, before the cube is dropped inside. So now we have 512 plus pi times 49 times 9 equals to pi times, now look at what we have here, still the radius. That's going to be 7 square, okay, times h. That's the new height. All right. So now, let's see, how do we do this now? So let's multiply this together, or you just make h to be the solid of the formula. Now let's make h to be the solid of the formula. So this comes under this. So we have 512 plus pi times 49 times 9, everything all over this. We have pi times 7 squared. That's the same thing as 49. equals to h. So this is going to be the new height. So now let's evaluate this. So you can compute that in your calculator. Let's see what we are going to have for that. Okay, so all right, so we have 512 plus. Now here you just have your pi is on your calculator. You can press shift pi. You have pi down, so shift pi times 49 times 9. Okay, so if you do that correctly, you have to have 1385.44. Okay, so everything all over. Now let's multiply this. The pi times 49. So when you multiply that, you have 153.938. So that's what we have. Okay. So we have h equals to. Now let's add the two and divide by the denominator. You have 512 plus 1385.44 divided by 153.938. So now what we have is 12.33 centimeters. So now the new height when this cube is dropped inside now is 12.33. You can see the height has increased, okay, from 9 down to 12.33. So, but what the question is asking for is the rise in height. So what's going to be the rise in height? It's going to be the difference between this new height and the original height. So we have, okay, rise in height of water. Now that gives us 12.33 centimeter minus 9 centimeter. So the answer is 3.33 centimeters. So this is going to be the increase in height of the water when the cube is dropped inside. All right, so I hope you understand this. Okay, so before we move to the next question, if you have any reservation, any question based on what you have done, so please drop that in the comment section. Let's see what we have before we move on. Okay, all right. Thank you, Satish. Okay, I hope I got that correctly. All right, so since there's no question, let's move down to another question here. All right, can we look at this next question? Okay. Yes, the question says a conical funnel, 12 centimeter depth and 15 centimeter in diameter, is full of liquid. It is emptied into a cylindrical tin, 10 centimeter in diameter. So calculate the height of the liquid in the tin. Do you understand? Now we have a conical funnel full of water. The conical funnel has a depth of 12 centimeter and a diameter of 15 centimeter. Okay, so now let's sketch that. So it looks like this. Okay, so and we have the diameter to be what, 15 centimeter. Okay, so this is down to this place is 15 centimeter, and we have the height. The height is 12 centimeter because that is the depth. Okay, the depth. So the volume of water, this conical funnel is full of water. Now the total volume of this cone is now poured into a cylindrical tin, which looks like this. Okay, now the cylindrical tin is 10 centimeter in diameter. So it's 10 centimeter in diameter. Okay, now when it is poured inside, it's going to have a particular height. Okay, and that's what the question wants us to get. What's going to be the height of the liquid when it is poured into this cylindrical tin? Now, what's the first thing to do? Let's get the volume of the water that fill this conical funnel. So let's get the volume. All right. Now, the first thing we need to get here now is the radius. Radius is half a diameter. So diameter is given to be 15. So radius will be 15 over 2. Okay, in centimeter. So that is the radius. And don't forget, if I'm to calculate the volume of this cone, that is volume is 1/3 of pi r squared h. All right, so in the question, we have the height to be 12 centimeter. The radius is 15 over 2. So now let's plug in the values here and let's see what we're going to have for the volume. So we have volume of the liquid will be 1/3 times 22 over 7 times 15 over 2 times 15 over 2 times the height, that's 12. Okay, so now 3 goes here is 1, 3 goes here is 4. Okay, So we have 2 goes here 1, 2 goes here 11, 2 goes here 1, 2 goes here is 2. Okay, so now we have volume of the liquid in the conical funnel is 11 times 15 times 15 times 2, everything over 7. Okay, so now can we evaluate this now? So I want you to do this and tell me what the answer is. So I want you to do something there. All right, I hope you have your adding machine. So compute this and tell me what's going to be the answer. So 11 times 15 times 15 times 2 over 7. Okay, so what's the answer? So if you have your answer, drop that in the comment section. Let me see what you have. All right, anyone? Okay, I expect every one of you to do that easily. So just compute and tell me what you have as your answer. Yes, is anybody dropping an answer? Anybody? Okay, it's not difficult. Don't you have your calculator with you, or you can divide straight away? Okay. So what you're supposed to have, if you do the numerator, you're supposed to have 4,590. Okay. So that is what I expect you to have. Okay. Is anybody with that answer? Nobody have dropped an answer. All right. So that's what you're supposed to have. So then, okay, so that's 4,950. Sorry. Okay. So now we now divide. Let us divide now here. So 7 goes in 49, that is 7. Okay. 7 goes in 5, that is 0. 7 goes in 50, that is 7. Okay. So we are left with 1 over 7. So that is that's what we are supposed to have for the volume in centimeter cube. Okay. All right. So that is the volume of the liquid here. Now this volume, we are pouring it here now, so to know the height. So so we now have the volume of the cylinder now. That is what? Pi r square h. All right. So now we already know the volume of water inside this cylinder. Okay, to be this. Okay, let's use this one. Let's work with this. So we have 4,950 over 7 equals to pi times r. Now r in this case, now look at it. The diameter here is 10 centimeter. So and the radius is half the diameter. So that means radius here is 10 over 2, and that is 5 centimeter. So that's the radius. So here we have 5 raised to the power of 2 times height. We're actually looking for this height. I hope you understand that. Okay, good. So what do we do next here? Let's come over. All right, so here, now we can divide both sides by pi times 5 raised to the power of 2, so that we isolate h. So we have h to be equals to 4,950 divided by, so this one comes under 7 times pi times 25. Okay, so that's what we have. So now can we get the height now? Okay, so now, so compute this and let me see your answer in the comment section. What do you have for this? Yeah, now, so what's going to be the height? Yeah, so can you do that now? So do that and drop your answer in the comment section. Let me see what you're going to have for that. So I told you this class is going to be interactive. So every one of you should participate. So make sure you are participating. Okay. So now when you evaluate that, what are you going to have? What's your answer? Is anybody dropping the answer to that? Anyone? Okay. So now if you do it correctly, you're supposed to have h be approximately 9 centimeters. So this is going to be the height. Okay, so if you evaluate this, you can just punch your calculator. This divided by 7 times pi is in your calculator times 25, or you turn this to 20/7. So you have an approximate value of 9. So that is the answer to that problem. Is there any question based on what you have done? If you have any question, please drop in the comment section. So let me quickly address that before we move on to the next thing. And don't forget, if you are just joining this platform for the first time and you love what we are doing here, please ensure you subscribe to this channel so that you'll be notified anytime you're on here. And also don't forget to tap the like button. All right, so any question based on what you have done? Any observation? Yes, of course, you can use calculator. That was what I said. You make use of your calculator. Yes, you can. All right. So, that is the answer. Right. It's not compulsory you have to make use of your calculator. You can also convert. This one is 22/7. Just change this to 22/7 and you evaluate. Okay, so now that is the answer to that. Okay, now let's move down to another question. All right, this is another question. Let's look at this question before we do it together. So I want you to read the question and digest the question. Okay, so now the question says, the circumference of the base of a right solid cylinder is 2 pi a centimeter and height is 8 centimeter. You have to find the curved surface area, and 2, total surface area, 3, the volume of the cylinder. The volume of the cylinder. So how does a cylinder looks like? So cylinder looks like this. Okay. All right. So there must always be a radius. Now the radius and also height. Height-ish. Okay. So now let's look at what we have in the question. Now, the question says the circumference of the base of a right solid cylinder is this. So, the circumference, you know the formula for circumference. So, this is the circumference of the circle. So, we have circumference of the base circle is this. So, it's 2 pi a. All right, so that's what the question gives us. Now, what is the formula for calculating the circumference of a circle? That is 2 pi r. So we now have 2 pi r equals to 2 pi a. You get that? This is the formula for calculating circumference of a circle. So in the question, we are giving the circumference of the circle to be this. So now what you are going to do is you divide both sides by this. So that means r is a. So the radius is a. So this is a. And that's going to be in centimeter. All right. So now we now said, the question says height is a centimeter. So h is also what? A in centimeter. All right. The question asks you to calculate the curved surface area. Now, what is the formula for calculating curved surface area of a cylinder? So we have curved surface area is going to be 2 pi r times h. Okay, so this is the formula for calculating the curved surface area of a cylinder. All right, so now let us plug in the values. So we have 2 pi and the r is a, and also h is a. So we have times a. So the answer is going to be 2 pi a square in centimeter square. So now this is the curved surface area of the cylinder. I hope you understand that. Now the question now go further. Total surface area. Total surface area. Don't forget to calculate total surface area. It's going to be the curved surface area plus the area of the two circles. All right. So now total surface area So we have the curved surface area. So total surface area is the area of the two circles, that is 2 pi r squared, okay, plus the curved surface area, which is this. That's going to be 2 pi a squared. 2 pi a squared. All right, don't forget, A is the same thing as what? Same thing as R. A is the same thing as R. So that means we have 2 pi A squared plus 2A squared. 2 pi A squared. Okay. So now when you add this together, okay, so you have what? You have 4 pi A squared. Two of these making 4 of pi A squared. So it's going to be in centimeter squared. All right, so that is the total surface area. Please, I want you to pay attention to the units. Units is very, very important. If you leave this out and you write the answer, even though your answer is correct, you'll be penalized for not putting the unit. So always remember to put the unit. Very, very important. Okay, so now the last one here is the volume of the cylinder. Volume of the cylinder. So what is the formula for calculating volume of the cylinder? So we have volume is what? By R squared H. By R squared H. So this is going to be the volume of the cylinder. All right. So now don't forget in the question we have H to be what? A. H is A and R is also A. So let's plug that in. So we have pi A squared times A. So our final answer is going to be what? Pi A cube centimeter cube. So this is going to be the answer to the problem. So that's the volume of this cylinder, okay? Cylindrical solid. All right, so yes, your observation based on what you have just done. If you have any question, you want to drop your thoughts based on what you have done, please do that before I proceed to the next question. Okay, okay. I want to believe we are good to go. We are good to go. So now let's move down to this. Let's move down to this question. All right. This another question. So let us see how are we supposed to solve this type of problem. Now let's look at the question. Now the diagram is the cross section of a solid in the form of a cone of height h and a hemispherical bowl of radius r. Now the volume of the hemisphere portion is half of the conical portion. Okay, so now you have to calculate the ratio r to h, the vertical angle of cone to the nearest degree, and the total volume of this solid shape, okay, to the nearest three significant figures. So that's the question. So now let's start with the first one we have here. All right, I want to believe every one of you can hear me. All right. Okay. So now let's look at what we have here. So we have the radius, we have the height, but I want us to pay attention to these details here. Now, the volume of the hemisphere portion is half of the volume of, okay, the conical portion. All right, so that is where we're going to begin from. Don't forget, this question is a composite solid. So we have two solids joined together, the cone and the what? The hemisphere. What's an hemisphere? Hemisphere is half of a sphere. Okay, half of a sphere. A sphere is just like your orange, your ball. Okay, so once you cut it into two equal parts, so a fraction of it is what you call a sphere. All right, so that sphere with a cone is now joined together. So this one is just the cross sectional area. Okay, so now since we understand that, now let's come back here. Now the volume of the hemisphere is half of the conical portion. So now let's say the hemisphere, the volume of hemisphere, let's say this volume here, the volume here, let's represent that with V1, while the volume here we represent it as V2. You get that now? So we have V1 for the hemisphere and V2 for the core. All right, so let's come back to the question. Now, the volume of the hemisphere, this V1 hemisphere portion is half of the conical portion. That is half of the conical portion. That is equals to 1/2 of this. Do you understand that? So that is what that statement is saying. Now, what I need to do, so since this relationship has been given, so let me get the formula for the hemisphere and the formula for the core. Now, what is the formula for volume of an hemisphere? All right, so that's going to be what? 2/3 pi r cubed. Okay, don't forget that an hemisphere itself, the volume is 4/3 pi r cubed. All right, all you just need to do is just to divide this by 2. Do you understand? Now, when you divide this by 2, you have this. Okay, so now equals to 1/2 of volume of a cone. All right, volume of a cone. So what's our formula for volume of a cone? Volume of a cone is 1/3 of pi r square ish. Okay, now don't forget, in this composite shape, the radius of this hemisphere is the same thing as the radius of this cone as well. Do you understand now? So that means R will be equal to R. Okay, so now let's see. What do we have now? Let's find a way of simplifying this. We have 2 over 3 pi R raised to the power of 3 equals to. Now this is going to give you, when you multiply, you open the bracket, you have 1 over 6. Okay, 1 over 6 pi R square H. So now what do we do now? So can I divide both sides by pi? So divide both sides by pi. So this one cancels this out. All right. So let me divide both sides by R square. Okay. So divide this by R square. That's 1. Divide this by R square. You have R here. You get that? Okay. So now the next thing I'm going to do. Okay. Let me bring it out. So we have 2 over 3 equals to you have R here. Okay. Don't forget. So now this is going to give you H over 6. H over 6. So here you can cross multiply. All right. So when you cross multiply, you have 3H equals to 12R. Okay, this times this, you have this, so this gives you this. But don't forget, what the question wants us to get is R ratio H. R ratio H. So now let me divide both sides by 3. So I have H equals to 4R. Okay, so now I can write it as 4R equals to H. So here, let me divide both sides by 4. If I divide both sides by 4, I will have R equals to H over 4. Do you understand that? You divide both sides by 4. So this 4 will have gone, so we have 4 under this place. Now, the next thing I'm going to do here, now divide both sides by H. Okay, so I'm going to have R over H equals to, so once I divide this by H, H will be here, so H will cancel H, so I have 1 over 4. All right, this is your H. So now you now have R ratio H equals to 1 ratio 4. Okay, so R ratio H is what? 1 ratio 4. So and that's what the question wants you to get. So this is the answer to the first. Okay, do you get that now? All right, so before I move on, any question based on that? Because we are going to be building on that answer. Any question based on that? Okay, if there's no question, so we have to go on. So that is R ratio H. So let's write the answer here. So this is the same thing as 1 to 4. Okay, so now let's move down to the next question. And the next question says you have to calculate the vertical angle of the cone to the nearest degree. The vertical angle. This is the vertical angle. So that's what I want to get now. So the vertical angle. So how do we go about that? Now the vertical angle, everything. Now you see this line coming down bisects this angle into 2 equal parts. Let's say is alpha alpha. It bisects into 2 equal parts. All right. So and this is a right angle here. So we can just look at it. Since we want to get this angle here, so we have, look at this right angle. I can bring out a right angle triangle here. So this is alpha. Okay, this is your alpha. This is h, which is the height, and this is radius. Okay, so I want to get this. So I'm going to be making use of trigonometrical ratio. Now look at this. This is adjacent. This is opposite. This is hypotenuse. All right. So now, so I'm connecting adjacent and opposite together. So what trig function will be that? That's going to be 2r. That's tan. All right. So opposite and adjacent. So I have tan alpha equals to opposite r over adjacent. That's h. Okay. So I have alpha to be equals to arctan of r ratio r divided by h. See, r divided by h is the same thing as r ratio h, what we have here. All right, so now instead of having this, we can just put 1 over 4 there. So we have alpha equals to 1 over 4. Okay, so alpha is arctan of 0.25. All right, so can you compute that? Can you compute that and tell me what this is going to be? You can make use of your 4-figure table or your calculator. Tell me what is arctan of 0.25. So if you are doing that on your calculator, just press shift and then you press the tan function and then go ahead and press 0.25. So whatever answer you have, drop that in the comment section. Let's see. So make sure you are doing something, just compute that and drop your answer in the comment section. Okay, is anybody with the answer? Oh, good. All right, I can see someone dropping 14.036. Okay, who is that? That's divine. Okay, and I have RG Zohan, that's degree. Okay, what do we have again? All right, good. Okay. All right. Okay, so now let's confirm that arctan of 0.2. Okay, that's good. So the answer is correct. We have 14.004 degrees. Okay, so that is what we have. So now, but the question says you have to correct to the nearest degree. To the nearest degree, that means to the nearest whole number. So, so alpha equals to 14 degrees. But don't forget, the question is asking for the angle here, not just a fraction of it, the vertical angle. So that is going to be 2 alpha. You understand now? So we have theta equals to 2 alpha, and that is going to be 2 times 14. So therefore, the vertical angle here gives you what? 28 degrees. So that is the answer to the nearest degrees. Okay, to the nearest degree, to the nearest whole number. So that's what we have. Okay, so I want to believe you all get that. Okay, so now let's look at the last one. Let's look at the last one. All right. Okay, now the question is asking for the total volume of the solid shape here, the composite shape. So we want to get the total volume. Okay, so what's the total volume of this? So now to get that, it's going to be the volume of the cone plus the volume of the hemisphere. So we add everything together. That gives us the volume of the whole thing. All right. So we have volume, total volume. That is going to give us volume of this cone. That is what? 1/3 pi r square h plus volume of the hemisphere. That is what? 2/3 pi r cube. All right. This is the volume of the hemisphere. This is the volume of the cone. All right. So we're adding everything together. So I want to believe we are all together. All right. So now let us now evaluate here. Okay. So here we can let's factor out r. So we have r. We can factor out r. We can also factor out 1/3. Can we do that? So that means we have r squared over 3. Okay. So now we are left with pi. Okay, we can also factor out pi as well. Let's factor out pi 3. So we are left with what here? We have h left here, and we also have 2r here. Okay. All right. So that is what we have there. Now let us now enter our value. So don't forget, here r is the same thing as, let's see, r is equals to, now let's first do this relationship here. We have r over h equals to 1/4. So when you cross multiply, you have r, 4r equals to h. So that means h is the same thing as 4r. So wherever we see h, we can put 4r there. Okay, so now let's do that. So now we have this expression turns to pi r squared over 3. Okay, we already know that h is 4r. So times 4r plus 2r. Okay, so now, so we have pi r squared over 3 times, when you add this together, you have 6r. Okay, so what's going to be the total? So everything, okay, let me write it here. So we have pi, or let's say now 3 goes there 1, 3 goes here 2. So that's going to be 1/2. Or that's going to be 2, sorry. So that's 2 pi r cube. So that is what we're going to have. You can see 3 goes there 1, 3 goes there 2. So that's the 2 we have here. So we have pi r squared times r. That gives you 2 pi r cube. So, and that's going to be the volume. That's going to be the volume in centimeter cube. All right. So that is what we have as the volume of the cylinder. All right. So any question based on what we just did here now? So any question? Any question? So if you have any question or any observation, please, I want you to drop that in the comment section. Any question? All right, so that is what we are supposed to have. But in the question, we are supposed to be giving value of the radius. So if we are giving value of radius, so that will help us now to be able to correct to 3SF. So now let us now use let's assume that R is 3.5. Let's make an assumption that R is 3.5. Okay, so if R is 3.5, so what is going to be the volume? Okay, can you do that and tell me what the answer is now? And you correct with 3SF. Okay, so this is the volume. So what is the volume to 3SF when given that R is 3.5 centimeter? Okay, yes, can you do that now and tell me what the volume is going to, the value of the volume? So to the nearest 3SF. Okay, so if you have your answer, drop that in the comment section. Yeah, so if R is 3.5, if R is 3.5, so what is the volume? What is the volume to the nearest 3SF? Yes, anyone? What is the volume to the nearest 3SF? Is anybody? Okay, I'm still waiting for your answer to that. You just need to plug in the value of R. It's not difficult at all. So what do you have? Anybody? Okay, because of our time, I don't think it's difficult. So since you have been given R, so you can plug this in. So you can get the value of R. So we have the volume, total volume is going to be 2 times pi times 3.5 raised to the power of 3. So you can compute that on your calculator and let's see what you're going to have. So that is 2 times pi, okay, times 3.5 raised to the power of 3. Okay. So what do we have with that? So the answer I have here is 269.3916 centimeter cube. All right. So now if you have to correct that to 3 significant figures, so that is going to give you 269.123 centimeter cube. So this is going to be the answer to the problem. All right. So that's the volume, the total volume. All right, guys. I guess you guys love today's class and you have learned one or two things. Okay, so we are going to be stopping here. So tomorrow is another day. All right, so make sure you share this video with your friends, and I want to encourage you, try and listen to my video. I've made a lot of videos on their mensuration, so you can always go through the video and ensure that you share the videos with your friends. Okay, so most especially those of you that are just watching me for the first time. So, and probably maybe you are finding the class difficult. Probably you can see how we are writing out the formulas and you don't know how we got the formula. So there is a video that I made on how those formulas were derived. So that's going to help you because that is the foundation you need under mensuration. Okay, so make sure that you look for the video and you listen and jot something down. All right, so thank you once again. Those of you joining for the first time, don't forget to subscribe to this channel. Thank you and have a nice time. Bye-bye.